Well, hello everybody. My name is Jonathan Taylor. I'm the Technical Marketing Manager for Civil Survey Solutions, and it's my pleasure today to introduce you to our technical webcast for what's new in AutoCAD, Civil 3D and Infraworks for the Autodesk release 2021. On that, it's my pleasure to hand over to Shane, who's the Technical Services Manager for Civil Survey Solutions. And no doubt, Shane, you've got quite a bit to get through, so I might just hand over to you.
Well, hello everybody and welcome. This session is really dedicated to highlighting what's new in AutoCAD Civil 3D and Infraworks for the 2021 release. So that's really what I'm going to run through. As per usual with these webcasts, it'll be a hybrid of showing you some PowerPoint and then leveraging in and showing you what the software does on those points. So I might just start waltzing on through. Okay, so AutoCAD 2021 has a number of improvements. So firstly, as per every year, speed improvements for saving, installation, 3D and 2D rendering. So there's probably nothing unusual in that. I think the last 4 or 5 years I've been saying the same thing. So they keep tightening that up and making that a cleaner, quicker run through. Some of the major items going through the bullet points from top to bottom rather than bottom to top, they've enhanced the drawing comparison. I don't know if anybody's played with that much since it was released in a big way last year, but that's certainly been enhanced. So if you open up drawings that are sitting on a cloud service, the cloud service actually holds revisions of those drawings. And Autodesk can connect to that cloud service and then allow you to review and compare across versions of the same drawing. So Dropbox, OneDrive, classic cloud storage tools. You can also compare changes across Xrefs. Really useful if you are underlaying somebody else's contribution to your work or that makes an impact on how you do your design. You can actually track and see those changes. So I'll show you how that works. The block library, which was certainly enhanced last year, really nice enhancements from a usability perspective. There's now a libraries tab, so you can hook into cloud folders or a local folder and basically leverage drawings from that folder. So if you think about it, you could make a folder location, store all your drawings in there that have great blocks, and then basically open those drawings and pull blocks across. From a pure drafting standpoint, there's been some tidy ups on trim and extend, the quick measure tools, revision cloud is now easy to sort of manage. I'll show you what they've done there. And they've added a break at point command, which I'll go through. That's the only slide for AutoCAD. So what I'm going to do now is flick over to show you that tool set. Okay, so there's 2 drawings in play that I want to talk about. So this one's called Pedestrian Plane. Basically, it's an Xref for this drawing. So if I type Xref, you'll see in here the cadastral plan is sitting there, right? So that's all cool. We'll come back to that. I will make a couple of changes in here and save the drawing, and then we'll come back and have a look at drawing history. So I'm just going to do some very basic things. I'll just create a few rectangles here to represent some new building pads, and I'll save this drawing. And then I'll be able to talk to you about drawing history with a little bit of relevance to what I just added there. Let's have a look at the basic AutoCAD drafting enhancements to start with. So I'm going to do a few things with just this very basic drawing. The first thing I want to start with is to talk about what's happened with trim and extend. So trim and extend now have a new mode, and you can go back to the old mode by clicking on mode here. But essentially what happens, instead of you firstly having to pick your cut planes and then start, the software just assumes that you want to have everything as a cut plane. Right? So what that means is when I hover here to do a trim, you know, it's going to delete. So that's another thing, delete the full object. If I hold down shift, I'm doing extend, right? Now I can also run the fence command straight away. Okay, so You don't have to type F for fence. Fence is assumed. Sorry if that was a bit of a trick there about trim and extend. If you hold down shift, trim becomes extend. There's nothing new in that. But the mode here is automatically to find all cutting edges. Okay, and fencing is you just clicking 2 points and drawing a line through. And I think that the lasso will be your friend here as well. So it's just made it quicker and easier for you to work with. As I sort of said, there is a mode down the bottom, so you can go back to the old mode where you pick your cut planes and then kick off. So that's really what they've done with trim and extend. One thing to note, and I don't know if this was really possible in previous trims, but you can now, if you get your cursor in the right spot, you can trim a hatch. Obviously, I'm not getting my cursor in the right spot here. Trim. Yeah, so you have to get your highlight right, but you can now trim hatches using the trim command. Okay, that's sort of trim and extend summarized. They've done some enhancements on the measure geometry. Now, if you are a Civil 3D user and you go to the Analyze tab and you start the measure command, it actually presets it to measure distance, but that measure geom command is really what you're after. What I'll do is I'll just flip to drafting annotation, and that will kick off the measure geometry command the way I want. So you see measure here, and it starts a quick measure. So this was sort of introduced, I think the last release, this measuring tool. So it's quite neat. Whatever those orange rays strike is really what you're going to get measurement information about. Now the enhancement is if you click in enclosed areas, then you get area and perimeter information presented when you click. That's really the big throwaway there on what they've added to measure geometry, really the ability to quickly measure area perimeter for enclosed spaces. Okay, moving on to the next point in the AutoCAD land is to talk about what they've done with Revision Cloud. So this seems to get improved every release. They tend to try and make it easier and easier and easier. So when you go to draw a Revision Cloud, certainly you can pick how you want to start. I normally use the command line to kick off, but you can use the obviously the ribbon, but I'm going to run a cloud here. So some of the things about the cloud drafting is that it actually does a better job picking a size now for an appropriate arc size. But the most important sort of improvement they've made to make it simpler is the arc length is exposed as a property. So you can just quickly make changes to that, review the outcomes, decide what you like, and push that around. So previously you had to dive about to change the arc length. So I'm really just trying to simplify that cloud review and cloud drawing process. Okay, now newish command. I mean, we sort of know how to break objects because we would have used break and just done 1 point, but there is a command under modify which is break at point. Okay, now I don't normally run break like that. There's actually a dedicated typing command, break at point. So break at point really lets you pick an object and then obviously break at a point. But the thing you can do is if you pick a starting location and you can get your extension to run, which drafting wise is giving me a bit of a headache. There we go. I can get that extension to run and then type in 10, and basically I've just broken that object a distance of 10 meters up. Okay, so if I run break at point again, and I'll break this object right there will do. Now I'll sort of split that up into two. So it's just another variant on the break command, allowing you to sort of split up in a slightly easier way than using the standard break command. Okay, so I've made a bunch of changes to this drawing. Obviously, I've done some trims and the like. So what I'm going to do is save that drawing, go back to the base drawing. Okay, so the base drawing is Xrefing that other drawing in. And it actually flicks me a little bubble notification here to say, hey, Shane, that's me, has edited the Xref. Do you want to look at it and run the comparison? So when I click on this link, what it will do is it'll open up the Xref comparison. So what you're currently seeing in the drawing and what the Xref changes are. So green is new or moved, red is deleted, grey is unchanged, and then you've got these revision plans that go around. Now, you do have control. You can ignore the stuff that's not different, highlight that away, stuff that's not compared, and then that really focuses you on what's changed, right? But the idea here is to really make it easy for you to see what's changed underneath your main plan, so what's changed in your base plan. So that's really that next level comparison. It's better to see through the Xref what is different. Okay, so the next thing to talk about in terms of that comparison is what they've done with comparing within a drawing. So this does rely upon you storing the drawing on a cloud service like OneDrive or Dropbox, something like that. Autodesk can now log you into that area, that service, and then leverage out of their version history for the current drawing. So if I click on version history here, or DWG history, and I give that a moment, it's actually recorded all the times I've mucked around with this drawing. So I saved it at 107. If I click on, hey, what did it look like at 9:44 this morning? It's now showing me the changes I made between 9:44 this morning and 1:07 today. So anything new is green, anything deleted is red, or anything modified is green as well. And then you can sort of see comparison. And it's not two separate drawings, which is what the drawing compare tool is really all about. It's actually within that current drawing, the history of changes every time you save. Okay, next in AutoCAD really is to talk about what they've done with blocks. So I'm fairly lazy when I can get away with it and my memory works. I is to insert a block. So what they did last release was really enhance this panel here. The ability to, within a drawing, you just quickly click. But I mean, I love this repeat placement. That's cool. You can just dive around. Recent allows you to look at your recent blocks that you've worked with, and then libraries lets you pick a folder, right, and then see all the drawings that are contained within that folder, right? So if I flick to Dropbox here, these are the 3 drawings within that top tier of the folder that I selected for Dropbox. Now I can click on one of those drawings and then get the blocks out of that drawing and drop into this one. So I don't know if there's actually anything new in terms of blocks in here, but I could leverage out of here and start dropping into this drawing. So yeah, so redefine the block, of course, because it already exists. But yeah, you have the ability to sort of leverage a lot easier across multiple drawings to get blocks. And if you use this smartly, this could be your, I guess, your block resource area, where you have a drawing that can, or a number of drawings that contain great blocks, and you can just open those drawings up and grab the blocks you want when you want. Okay, look, there's a bunch of other improvements, but that's really the main improvements that's happened with AutoCAD. So improved, I guess, comparison of when changes have occurred, improvements to block insert, and then a collection of drafting enhancements, so tweaking commands, making them run faster and more automated. All right, so what I'm going to do is close these drawings down and then I'll go back to the PowerPoint and we'll talk Civil 3D. So let's close that down. Let's go back to this PowerPoint. Okay, so in talking about Civil 3D, I actually immediately need to talk about Infraworks. So Civil 3D has 3 or 4 sort of enhancement areas, but the big thing they've done is improve the integration between Civil 3D and Infraworks. And I'll talk a little bit more about that and the ability to use Infraworks as a representation of your design as opposed to a conceptual design tool. Because I think a lot of customers would rather that conceptually design, not conceptually design it, but visualize your real design in context with what's there. Civil 3D, the big piece really is this new bridge workflow. They've made improvements to pressure networks, Dynamo, which is the visual programming application used extensively in Revit. Was put in Civil 3D, I think, a couple of releases back, but they keep adding to that, the pile. And Dynamo will let you, I guess, do some programming things that is sort of partway between Lisp and then .NET programming. So it's a visual programming platform. And then there's been a couple of improvements to Arcgis. But I'm going to spend a fair bit of my time talking about this workflow. And it's not just about bridges, it's really about connection between Civil 3D and Infraworks. So in Civil 3D, what we will see is there's a new object type, which is called a bridge. And it's basically created via Infraworks. Infraworks is a feeder to Civil 3D. Civil 3D can now properly interpret a bridge that's coming from Infraworks. That share actually goes further than that. Infraworks is an initiator of a bridge represented in Civil 3D and also can be sent to Revit for detailed documentation and publication. So I'll talk to you a bit about how Infraworks is more tightly integrated to Civil 3D. At the actual Infraworks level, and this is where I'm jumping Civil and Infraworks in the same sort of discussion, Infraworks is going to better represent what you design in Civil 3D now. So instead of having these stylized representations, they've done a lot of work to properly represent what you've designed in Civil 3D. Moving on from there is that structures workflow. So this ability to interact between bridge layout and creation in Infraworks and moving it back to Civil 3D for publication, consumption on the long section, and across to Revit for publication. So big piece, but that's what I'm going to talk about now. Next is pipe networks, but let me go back to Civil 3D. Okay, so I'm going out on a limb here in that I currently don't have a corridor, so the usual place people would start is already have a corridor and talk about the new feature. I'm just going to quickly make a corridor, and I'm going to take the opportunity to talk about civil site design, creating that corridor, but forget about those steps if you're not a Civil 3D user. We'll get to the point very quickly of having a corridor and then making use of that. So I'm just going to go through civil site design to make that corridor. If you're not a civil site design user, you have an alignment. You would go and create design profiles for each alignment. You would then add assemblies. You would then create corridors, and you would then work over the intersections, either with the intersection tool or editing the corridor to make intersections. So I'm instead going to go through that process by just quickly creating a road network. So I'm creating just a road with some cross sections here. So this is just for me to get a connection. I'm just going to delete IPs that I don't think add much value to me. Then I'm going to edit this one and make that a bigger curve length, that's all cool. Simple design, that's good. Happy with that. I'm then going to create this road here, and what you'll see is that there's actually a natural valley here, and I really want a bridge. That's what I know I need to do for whatever reason. I am hitting residential, but I'm over that. I want to throw in a bridge. So I'm going to design this vertically for a bridge. So all I'm going to do is pull out some IPs and we'll slide this up, and I will edit that curve length, make it somewhat bigger. Okay, so I've now got bridge. There's a 10-meter rise, probably reasonable process there for warranting a bridge. At the moment, cross sections are battering, so that's all cool. Okay, let's just quickly connect the dots here and join the roads together. Some curve returns. So I can build a surface out of this and go through all that process, but ultimately what we need to do is get to a corridor. Because once we get to a corridor, then we can talk about sharing that with Infraworks. So I'm going to go to the outputs here and just create a corridor of this. We'll call this road network.
Just while Shane's setting up, for those of you that haven't seen this particular tool before, there is an in-depth webcast that we undertook in March, which basically goes through how to operate the particular tools that Shane is showing you. So if you do want more information about this, have a look at the webcast playlist and head down to around about March time, and Andrew Banson did a very thorough webcast on these particular tools.
Thank you, Jonathan. You filled that, that waiting void beautifully. Okay, so we have a corridor out of this process. All we're going to do is save this drawing. So with the corridor, you know, it's really well defined in terms of the section pairs, the codes, the links, the shapes, all this business through the assemblies that have been created, right? So I can spin it in 3D and go wax and lyrical about it, but there's full shapes, links, and corridor feature lines that represent that 3D entity. So what I want to do is push this across to Infraworks, and I'm thinking about this as a design outcome rather than a conceptual layout to get stakeholder approval and get a project up and running. I really want to use Infraworks as that sort of final output, slightly shy of what 3ds Max could do, but an output of my design in context with what's already around. And that's really where Infraworks can come into play at that front. So I'm not going to talk too much about everything that Infraworks can do. I will say that they keep simplifying their interface. So you can see that they've ribbonized the environment. Creation tools are here with a drop down to create items. Now, if you have a look over at this panel on the right, this is the data sources. So this is the origin of data that is represented in Infraworks. And you can see here that what I've actually done is typed in this location, which is Mollymook in New South Wales. And I said, hey, give me terrain data, give me aerial photo, give me roads coming through web services. But this surface is actually the detailed survey surface from Civil 3D. So that's already happened through an IMX. But what we're going to do now is add the roads. So I come down here and I say I'd like to pop in the Civil 3D drawing. And then I have to find it, and it should be that one. Timing looks good. Okay, so you just pick the Civil 3D drawing. Software will then ask what you want out of it. I really just want the roads. So I'm just going to grab that. And it throws it in because it knows what a road is. Now I'm going to configure this to bring it into the drawing. And something very fundamental is changed here to talk about. So the big change is this tab and what it actually means with the road options. But first, I'm just going to turn off the roads that I haven't designed. So rather than them coming in as conceptual roads, I will not ask them to come in. But you'll see when you bring in a road now, you can either bring it in as a component road, which lets Infraworks interpret what the section should look like, or you can bring it in as a corridor component road, which is basically what the corridor wants, the corridor gets. Now, the mapping of that I will talk about right now. This button here called Component Mapping Settings really lets you do what you would have done in Civil 3D with corridor code sets. You can type in, pick subassembly names, shapes, link codes, and based on those Civil 3D definitions, you can then assign them to a category in Infraworks. Right, so this basically lets you get down to the level of the different pavement layers, and certainly the top surface layer. How is that being interpreted? Right? What does it represent? Is it roadway? Is it generic? Should it be grass, concrete, and all those bits and pieces? And you'll see down here the definition for the top surface links and datum. From this, you can quickly interpret the surface and get surface information out. So this is the big enhancement, the fact that you can really get down to the fine level of the corridor and its elements and map it correctly how you want to Infraworks. So I'm going to close and refresh this. I think my geolocation is good. Okay, so this looks quite different to how component road looks, right? So what it's actually doing is pulling your design, your corridor design, and representing that as shapes and features just like you would in a corridor. Okay, so that's step one. You can pull a design in and get a lot more realism based on what the design intent was now from Civil 3D to Infraworks. Okay, I'm going to put a bridge in here, and the intention is to then use that bridge layout as a catalyst for viewing and documenting the Civil 3D and viewing final editing and documentation in Revit. So to add a bridge, I can go to Create and select Bridge, or I can just click on the road, right click, and I can add bridge structures, right? So pick or choose, very graphical, very friendly at that level. So I'm going to add a bridge. And all I do is I pick a start position, so you can see graphically the little roll bar of where you are. I'm going to type in 40, and then I'm going to come out to around about here, which is what, 150, let's say. Oops, 40 for the start. I'll get there. 40 for the start, and I'm going to go tabbing through here, 140 for the end. Okay. Well, I left it 136.662, but I can move it around later. Okay, so what Infraworks has done is it's had a look at the Australian standards. It's worked out that it's probably good to have a couple of piers, and it's also established a girder arrangement for structurally how you want to support that. Now you can play around with the girders just like you used to. Here I am dragging them out a little bit further. But the bridge is made up of piers, the deck, the girders, and the abutments, the bearings, all the features you'd expect out of a bridge. Now, if you want to make a change to the bridge, you can click on an element and you can rotate or move that element. And you can also change a whole bunch of parameters. Something that I think has been enhanced is this idea of pushing the data to spreadsheet and editing in there. So just so you know, you can create a spreadsheet of the bridge detail, and you can edit this spreadsheet and also write that information back. Okay, so I'll have a go at this. I'll make this 160 on the nose and see what it does. Might not take that, but we'll see what it does with that. But I'm having a look here at the piers, right? See there are two piers, and just for fun, I'm going to put a rotation on one of these piers just so we can see it change, and I'm going to save this. Okay, so Excel spreadsheet. What I can do is now go send a spreadsheet, and if I choose update existing, basically it will read out that spreadsheet, the spreadsheet changes and apply them. Okay, so this is certainly a nice spreadsheet way for you to initiate, execute changes for your bridge. Okay, so I could click in here and play around with the girders. I could go to individual girders and muck about with them, but I'm sort of happy with this bridge right now as it is, and I want to talk to you about sharing it back. So sharing back the bridge is a matter of selecting the bridge and publishing it as a civil structure. And you'll notice here that there are two options: create new and update existing. This is deliberate. This is so that you could update the bridge changes from Revit. And create new is so that we can publish it out to Revit and to Civil 3D. In Civil 3D, you'll have also a reload and an update. So there's now quite a good reflection between those three different products and a good share. But I'm going to go create new. I always forget where this is going to live, but just put in, there's this backup, import, Civil 3D1, weird location. I'll find it. Save it there. So what this is doing is packaging up that information. And I'll let it roll through its cycle so you can see it into all its glory.
Folks, don't forget that we've got a Q&A panel, so if you do have any questions about what you're seeing, then feel free to use that at any point.
We always wonder when there are no questions whether it's just you know, shock and awe.
That's exactly what I think it is, Shane. It can only be that, surely.
I'll assume that's the case. Okay, so we've basically made a file, a transactional file now that we can share about. So I'm going to share this to Civil 3D, and then I'm going to, looking at the time, I'll go and share it to Revit just so you can see that go in. So what I'm going to do is pull that data in. If I go to Infraworks and open model. So the only thing with working with Infraworks and with Revit is agree on a coordinate system. Okay, so it's really important that you all agree on a coordinate system that you're going to work with, and that is the same all the way through. It's probably the only big principle that you need to make sure you've got in Infraworks. Certainly at georeferences, Revit will now, and Civil 3D, as always, wanted a coordinate system. So I'm going to bring that bridge in. If I actually have a look at the data that's in the Infraworks file, I'll try unticking these surfaces and not bring those in. It is demanding I bring in the existing ground, but I'll delete that when it comes in. I don't really need the road, but I'll bring it in so you can see it, and I've got the bridge. So when I click on open model, software will then read those elements in, and then, and I probably should have overviewed this earlier, we can talk about this new object called a bridge. So what's actually happened, if I just grab this and look at it in 3D, what we'll see is this is the corridor that Infraworks has sent back to Civil 3D, but you can now see that Civil 3D is representing that bridge, and probably most importantly, it actually has an understanding on what the different elements are. Okay, so it's not just a blob, it's not just a block. It understands the abutments, the girders, the foundations, the piers, the deck. Okay, so that's what it looks like in 3D, but what you'll see here is the original corridor and then the adjusted corridor, right? So I'll just say this, if I make changes vertically or horizontally in Civil 3D, all I need to do is save the drawing, go back to Infraworks and say re-import, and it will update the geometry. The bridge will move vertically, horizontally based on the changes I make. What I really should do is get in and apply a deck cross-section in this zone, right? Which I can do either using Civil 3D by splitting regions or using Civil Site Design and updating the corridor. So I will cheat and take option 2, but I'll delete this base because I don't really need to see it. And I will update the real corridor. But the next steps is to talk to you about that bridge production to Civil 3D. And the play for Civil 3D is, wouldn't it be nice to show this on the long sections and get some information on there? So I'm going to run this command from Civil Site Design only because I've designed in Civil Site Design. I'm going to write the profiles out to the drawing. What that will do is just create the profile views of the design in Civil Site Design. But what I want to do is put the bridge on here. So I click on the profile view, and then up the top here, I say project objects. And all I need to do is what you'd normally do to project an object. You pick it, press enter, and you can pick any part of the bridge, and then it's going to push across the bridge. Now, in the settings, you have styles for how you want to draw, or not draw, but color and describe visually the pier, the girder, the abutment, the deck. And it has split up the information, right? So understand each girder, you could separately represent those as you will. And you can also label them differently. So I think we'll end up with a bucket load of girder labels we don't really like. Maybe I'll just change the style of that to not display. So I'm back-ending in to turn these labels off because I don't really care to see those ones. Oh, the girder group was all right. I think I went a bit deep there. These ones I don't really want to see. Yeah, it's already false. Cool. All right, so what I'm going to do now is click OK. And when I go and have a look at that long section, you can see that bridge is included. And then you can document how you want to document. It's the bearings that I didn't want to see. But I've got here the deck, chain edge and level at the start, the deck, chain edge and level at the end. And I could move those labels around and push them however I want. Oh, that's the abutment. But there's documentation. The piers can be documented with elevation information, but it's now included and incorporated in that log section. Now, just repeating, if I change my design, all I need to do is save the drawing, re-import in Infraworks, it will update, and then I cycle through just updating the structures again. Okay, so it is a two-way street. I'll just tidy up the design here. What I'm going to do is pop in here and just quickly throw in some change or cross sections. So I don't really want to see that. I just want to see the deck. So I'll just quickly change that. So I'm going to change the cross section in multiple locations. Okay, so I'm going to keep it from 0 to 40 with the road, then from 40 to 160, let's say. I'm going to go with just the deck. Okay, so I do already have a template. It's just going to be the road pavement. And then from 160 onwards, I want to go back to my road. Okay, so you'll see the cross sections change. And to update my corridor, I just go sync and it will sweep through and make those changes. Okay, so it'll cut in the region for me, change the template, and pop those changes across. So you can see that sort of happening. Now it's building basically what you see on those sections.
Shane, we did have a question come in which was related to if you decide that at some point during the two-way process that you want to maybe make a change to the vertical design in Infraworks, is that going to be possible? So I suppose, yes, there is vertical design tools within Infraworks to enable you to edit individual IPs, but I guess it's not quite as comprehensive as doing it within either Civil 3D on the profile or within the Civil Site Design.
Well, yes, but if you have a look at what I've just clicked on now, I've got an alignment called Bridging Road bracket 1. That's actually been inherited from Infraworks. So If you want, you bring it from Infraworks. It'll put a bracket 1 if it's a renaming, but that is the new profile from Infraworks is there. Now, they're actually the same, but yes, if I change the Infraworks, I could shoot it back. It creates an alignment, creates a profile that I could then use. The only thing you want to do is have a look at the naming convention of the profile. Let me just have a quick look and see what it's called. Yeah, so that's the sort of naming convention that pushes back, right? That's the Infraworks names. If we have a look at the profile names that Civil Site Design makes, they're quite specific so that you can update. All right, hopefully that sort of answers the question, but I repeat, this is a two-way street, okay? So if I went in and edited this profile, and then I went back to Infraworks and did a re-import, I would get new elevations, new bridge elevations, so on and so forth, okay? And then all I'd need to do is to do exactly what I did to get the bridge in here. It would update against that file again. Okay, so I will leave it at that for the moment, and I'll just put that out of whack. If I go to Infraworks, well, I did change it slightly vertically, so hopefully we'll see this. All you need to do is you right-click here, you choose Re-import. It will do a full read-in of the vertical design that's come through this process, and then we'll update elevations, plan geometry accordingly. Right? And the bridge will swing and sway based on those changes to get the deck matching up with the profile. While that's, I'll let it do its thing so we might see it, might notice it. I probably didn't make enough of a change, but that has lifted. I think you need to go back to the video recording and, pause, fast forward, and then quickly look. But that will have been lifted. So yeah, it's the two-way street. Just while I'm here, let's just quickly look at Revit. I will confess I'm no Revit expert by any means, but I'm going to show you this process of how you would move this data across to Revit. So I'm going to go with, well, there'll be a new 3D view created in a moment. When you're in Revit, you do need to install an optional add-in, which is integration or connection collaboration with Infraworks. But once you do that, you'll actually get this button here, import civil structures, and then check for updates. So that's your revision update. But if I go import civil structures, I go and find that file, which is this one here. It's the right date and time. Revit will then read that data in. I can change it here. I can send it back, update Infraworks and cycle that way, or I can change Infraworks position elevation and send that back to Revit. So let's wait for that to finish its process. But you'll see now there's a new 3D view. So this is it in Revit, ready for me to do that finessing that Revit can do through the families. All right, maybe publishing sheets, sectioning, and finalization through Revit. All right, hopefully that gives you a bit of a taste of that cycle. Okay, Infraworks has some improvements for 4K, so it does a better job with 4K monitors. I'll show you a screenshot of that rather than trying to show it. It's sort of impossible unless you've got a 4K monitor or you're able to flick between. But yeah, the real big deal is that connectivity, that sharing that's happening around now. Spreadsheet, bridge, those are the main aspects. Just while I'm here, if I choose here to show the cross-section, you'll see that cross-section looks very much like what you designed, okay? So that's the better reflection of the information. All right, so that's the sort of interaction worked out there. Let's talk about pressure pipe networks. So for those of you who've tried working with pressure pipe networks, maybe like I have, you've had some good experiences and some average ones. I found that the pressure pipe networks were a bit of a challenge vertically. What I do want to say is that they've done something great. You can now sort of link your pipe design with an alignment, and the alignment can control the positioning and then updates the elbows and the bits and pieces. And you can also link to a profile in Civil 3D. So I'm just going to quickly push through that process. Close this drawing and just open a new one. I say new, but it's not really new. And it's located here. Pressure pipes. Okay, so this is actually the same as the other drawing. I just cleaned it out a little bit so that it was a bit nicer to look at. And what I want to do is focus on what they've done with pressure pipes. So I'm going to create a pressure pipe using this polyline. Okay, so it's just a polyline, and the only thing in here really is polylines and a surface, right? But what I'm going to do is create pressure pipe from objects. I pick the direction, and then it's actually going to define a pipe run. So we'll see when we look in the node for pressure networks, you now have a new classification, which is pipe run, and that sort of links it back to alignments. I'm going to use 90mm pipes. I'm going to pick surface to basically follow, right? And when I do that, I can then pick a depth below that surface. And it's a great starting point for what happens vertically. I can also offset. So I'm going to offset 2 meters to the left of that line. Once I click OK, the software will then go and create the network, right? I'll just quickly label it so we can sort of see what it's done. So up here, I'm just going to add plan labels. Okay, so you can see it's put some elbows on. The most important thing to know is that you now have this opportunity to sort of link it through what's called a pipe run, and that ties it to an alignment, right? So the actual alignment here, essentially, is driving the geometry. Now, if I move it, say, this way, you'll see it will change the elbows automatically to try and find the closest fit that it can, right? So it's a lot easier graphically to handle it that way. The arc has automatically been handled. If you change the arc, which I probably should because I'm looking at tangency there, you'll see that the arc will adjust. Now, vertically, what you can do is review the profile. And this is a lot more tied to having a Civil 3D profile driving the event outcome. And I'm going to start by using the surface profile I got created. Okay, I can just pick natural surface. We're going to use the surface profile. And you can choose to either just have straight lines between, or to allow for cut length to be used to trace the land. And I'm just going to pop a profile view out of that. That's all good. I'll create a profile view over here. And what we'll see is that we'll have the pipes included in that view. So you can see there, I've now got the pipe network chasing the elevations of the land there. Now, what you don't see is that there is actually a profile that's been dropped down and that's being used, okay? So what I'm going to do is to design in a sort of drop, okay? So I'm going to change this up a bit and say, well, vertically, I need to have a drop to get under some other service. Now, the way I do this is just by creating my own profile and using that. So I'm going to go profile creation. This is pipe. And I'm just going to quickly knock this out so you can see how this works. Okay, so I'll just go use this one, do a quick push through. Just that one there. And I'll snap on here, and then I'm going to turn off my snaps. And what I'm going to do is do a flat area here, and let's say there's some obstruction in this place. I'm going to sort of kick down here with the profile. So basically I'm using this profile to set what I want to have happen with the pipe geometry. Do another drop there. And run this down, just quickly push it out. Okay. So what I can do is now click on the pipe and change where the pipe gets its verticals from. So I'm going to click on this pipe, and up the top here where it starts to talk to me about the pipe run profile, you'll see here that it actually tells me what profile it's currently running against and the vertical offset. If I type in a different vertical offset, I'm just going to drop that down. But what I'm going to do is run pipe run profile, and instead of hooking onto NS, I'm going to hook onto pipe. So that is just going to change the reference for the elevations of that pipe. And you'll see it's going to be a metre below whatever I've drafted here with the profile. Okay, so I could change that offset to 0.5, and then it will move everything up to be half a metre below that line. And I can click on that profile. Any changes I make to that profile is actually going to reflect through what's happening vertically. So now alignments and profiles have a much stronger emphasis on what happens to the design. Okay, you can detach that, you can break that apart, throw it away and go with the old method, but while you're in that mode, that's the way it happens. Now what I'm going to do is just very quickly make a new one. So I'm going to click on the network here. That's going to offer me to do a new pipe run, okay? So I can do it from objects, or I can do it just on the fly. I'll do 90 mil again. Wash the surface. Okay, so what I'm going to do is click here and run it out. Okay, so let's just quickly run it like that. So the other changes, which hopefully you can see on the ribbon, it's very easy to add bends. So the add PI will put a bend in, nice and simple. And this button here, add branch fitting, it would handle these issues if they weren't already connected. So if you just pulled that line up, branch fitting would actually fit the branch in and put the T in, okay? But if I wanted to add a bend in here, I'll get add PI bend, and I want a dog leg around here. So click, and put in an IP, and then I'll be able to move on from there. Okay, so there we go, I'll put that in a stupid spot. But you can see there I've just added a kink in a really weird spot. I think my snaps are all over the shop. But I'll leave that at that. But they're the improvements to the pipe network, pressure pipe network, this idea of a pipe run, branch fittings, and then adding IPs where you want to add IPs. Okay, so they've certainly improved also the information on the long section, so you can put it in a band. Okay, the next bit, I will sort of skip this out of order a little, and I know I'm sort of over time. So the Esri connection. So I'm not sure how many of you have used the Esri connection that's in the system, but if you do use Esri and leverage that web service, you can move your data from Civil 3D to Esri. What they've added is the ability to better associate the GIS attributes with the Civil 3D attributes. So if you think about pipe networks, invert levels, pipe diameters, and all those sorts of things can be given an Arcgis attribute. I'll just quickly show you where that lives. I won't go through the whole process because I can see I'm already out of time. But you'll see if you look in, yeah, I'm undoing and redoing stuff. You'll see when you look in collaborate, publish to ArcGIS. Okay, so these are parcels. They have lot numbers, they have areas, perimeters, and those sorts of things. And I could then park them out into the ArcGIS system. and you choose what Civil 3D objects you want to pull out, right? Pipe networks, lots, points, alignments, feature lines can all go out to Arcgis directly. But this is what's new, right? So you've got your area that all looks good. You then get to define in here what attributes you want to push to Arcgis from all those attributes that Civil 3D is holding. You then give it a name. You then give it a summary, might add a few tags, and then you can choose who can see it. And then you can publish. All right, so this will publish it to GIS, and then I can open up the GIS environment and have a bit of a look. While that's processing away, I'll move on with the slides. So Dynamo keeps evolving quite rapidly. It is a visual coding environment where you grab nodes of activities, mathematical actions, gathering data from a drawing, and then you can execute change and draft things in the drawing or make changes in the drawing. So people are doing some great things with it to put a shell for a tunnel, to add features, 3D and 2D, to draft, to add Kogo points on blocks, all sorts of things. What's changed? You've got more nodes, so you can add multi-line text, Kogo points, property data sets, and then the custom packages, and there's a good one called Civil 3D Toolkit, will add more nodes, so more things that you can touch, attack, and change. And the Dynamo player basically lets you just play them instead of having to open them up and look at them in an editing format. Now, there are some videos to show on those, but I might just skip those for given that I'm over time. With BIM 360 collaboration, there's a whole bunch of slides that I can show you about how it works. Probably the one improvement they've made is a better tie-in with Xrefs and making sure that a drawing is locked in BIM 360 if somebody else is using it. So there's a whole bunch of things to show you about how it works, but they're not so much new features. There's a mix of new features and existing, but you see the lock there when you try and open a drawing. Then you'll see here about the lock in BIM 360, data shortcuts, and that they're managed. And then also that if you move Xrefs around, it'll tidy that up in BIM 360 land. That's all there is to say about that. Now, we are so close to done. I'll just show you this in Arcgis so you can see how this would work. So this is published to the Arcgis map. It's going to take me to where I want to be, but they're the entities that I've pushed from Civil 3D across. And when you have a look, the information that you managed in Civil 3D is tracked and kept as attributes in Arcgis. Certainly there's lots of things, more things you can do, good two-way streeting between Arcgis and Civil 3D. And if I look at the Infraworks improvements, there's the 4K improvements to better represent our 4K monitors. And then also the Arcgis connector has been added for Infraworks. Okay, they were all the main things that I want to show about what's new in 2021. Jonathan, I'll hand back to you at that point.
Yeah, thank you very much, Shane. That was fantastic. Obviously, lots of good stuff to get through. We are, yeah, as Shane said, we've just been go for time. But we had a couple of questions, one of which we answered live, another one which we've answered actually on the Q&A panel, which was related to alignments for the pipe networks. But other than that, it's been relatively quiet, Shane, on the Q&A front, which, as you say, can only mean that you're just blowing everyone away with your content, which I'd expect to be the case. Just while we sort of polish off, folks, if you do have any last-minute questions, feel free to pop them in. I will just quickly share my screen. I'm going to be just sharing sort of our usual PowerPoint that we pop in at the end. Shane, can you see that?
Yeah.
Fantastic. Excellent. So for those of you who want to do that particular rewind where Shane did the vertical design close to the bridge, the only way that you're now going to be able to do that is through the video on the YouTube channel. So have a look at that. You can also find the video, which I said was around the March, I think middle of March, which Andrew Banson did, the webcast on Civil 3D outputs from Civil site design. Well worth a watch, gives you a lot more detail about how that process works and the intention of those tools as well. Coming up in June, we've got next week AutoCAD Blocks and Attributes 101, which was really based on the consensus of the last AutoCAD Tips and Tricks webcast we did. We sort of did a poll at the end, and the consensus was that people wanted to see blocks and attributes. So that's the webcast we're going to be doing next week, followed by Stringer Topo the week after. If you do want to find a schedule of our webcasts for forthcoming weeks, and also register if you're not averse to waiting for the newsletter, then feel free to pop on to our webcasts page or live webcast event page found on our website, where you can go and get some information and register there if you want. Other than that, Shane, thank you very much for your presentation today. Still very quiet in the Q&A. Which, yes, we'll take as being a good thing. If you haven't, that's one of the things. If you've got any feedback about today or any suggestions about future webcasts that you might want to see, again, you can also do that through here, and it's anonymous as well. So you can pop on there and type some information about what you've seen today or what you'd like to see going forward, and we will take that on board. Other than that, please just say thank you very much, Shane. For that, I will end the webcast there. Thank you very much for your attendance today, and we look forward to seeing you at our next webcast. Thanks very much.